Hello everyone. Today we discuss each numerical of every sort. So first we discuss about the bubble sort. So the bubble sort takes n-1 iteration. In every iteration it tries to push the large number to extreme right position of the input, and after every iteration the problem is reduced by 1 from the right side. So how we sort? Let's we see. We compare two elements of every input. So first we compare 32 and 37, and which is the largest number we push means we swap them at the right side. So in 32 and 37 is the largest number, so we write as it is. So now we compare next two elements of the input, which are 37 and 23. Now 37 is the biggest number, so we swap them between each other. So this 32 here, now 23, we swap 23 and 37, 11, and remaining all elements are the same. Now we compare next two elements. These are 37 and 11, and 37 again is the biggest number. So now again we push 37 in right side. Here 11 and 37, 38, 41. Now again we compare next two elements, 23, 11. Now 38 is the largest number, so we don't need to swap them. So in this way we complete first iteration. Now we swap next two element, 11, 37. Now 41 is the largest number, so don't need to swap them. 41, 22. Now next two element, 37, 38, and now the 41 is the largest, so we swap 22 and 41. So in this way the largest number of the input is go at the right side of the input. In this way we sort all the iteration and we get the sorted array. So all the steps are the same for each iteration. Each iteration is reduces by 1, and see here we first sort 41, and next iteration we sort 38, and next one we sorted 37, and all the process are the same for each iteration, and at the last we get sorted array. Now we move for the selection sort. So in selection sort takes n-1 iteration. In every iteration we pick the smallest number from the input and place it in an appropriate position. The problem will be reduced by 1 from the left side after each iteration. So we see how to sort the given input. First find out the minimum number. So in this problem 11 is the minimum number. So first we give the index of the array 0, 1, 2, 3, 4, 5, 6. So the minimum number is present at the third index, so we write the minimum index here, and I is the sequence of the index. So start from 0 and minimum is 3. So now we want to swap this minimum number with I, means this 11 we put on the first index. So now here is the 11, we swap 11 and 32, 11, 37, 23, and now here 32, 38, 41, 22. Now we want second index. So now I is the 1, and now we see which is the smallest number from the index 1. This is 22. So now we want to swap this 22 with the second index of the array, which means this is the 37. So now the minimum is at 6th index. So 11, now here second index we swap with 22, this 23, 32, 38, 41 is as it is, and now second index is 37, we swap with 22. Now again our I is incremented. Now we check for the third index of the array. Now we check which is the smallest from the third index. This is now 23. So but 23 is the correct position, but we mention here. So now second minimum is at second index. So 11, 22, 23, 32, 38, 41, 37. Now again I is incremented by 1. Now we find out minimum from the third index. Now the minimum is 32, which is also as the correct position, but we mention here this is the third index. Now 11, 22, 23, 32, and remaining all are the right as it is. Now again I is incremented by 4. We want now fourth index. Now the 37 is the smallest number. So we swap sixth index with fourth index. Now here 37, 41, 37. Now I is 5 and the minimum here is 38. Now minimum check in 41, 38. So now again the minimum number is present at the 6th position. So we swap the value of 6th index and 5th index. 11, 22, 23, 32, 37, 41. Sorry, here is the 38. We swap 38, 8 and 41. This is our answer. Now here 1, 2, 3, 4, 5, 6, 7. Here 7 values are the present in the input. So our iteration is 6 and minus 1. This is 1, 2, 3, 4, 5 and 6. We perform 6 iteration and 7th one is our answer, sorted array. So I hope you get idea about the selection sort also. Now we move for the insertion sort. So in insertion sort, the problem is divided into two parts, sorted and unsorted. Initially, first element is by default sorted and remaining n-1 element are unsorted. Insertion sort execute in n-1 iteration. In every iteration we pick one element from the unsorted part and place it appropriate position in a sorted part using the displacement. So we see how we perform in insertion sort. So in insertion sort we know first element is by default sorted and we put second element as a temporary element. So first we take 37 as a temporary element. Now we check 37 is the smallest from the sorted array. No, 32 is the smallest and 37 is the largest. So we do not change any element. Now we move to the second iteration. Now our temporary element is the 23. Now we check 23 is smallest from the previous element as 32 is the. Now our temporary element is 23. Now we check 23 is the smallest from the previous element. Yes, 23 is the smallest element, so we push forward. Then again we check 23 is the smallest. Yes, 23 is the smallest from the 32, so again we push forward. So in this way we put 23 in the first index. Now our temporary element is the 38. Now again we check 38 is the smallest or the largest, and if 38 is the smallest then we do Vj minus minus and we put temporary element at their appropriate position. So in this way we perform insertion sort. Now the merge sort. Sorting problem can be solved using the recursive approach. It uses divide and conquer strategy. The sorting problem is divided into a small parts until the one element is remaining in the smallest instant. One element is by default sorted. Then apply the merge to get the result of the original problem. So how we solve? Let's see. First we give index of each array 2, 3, 4, 5, 6. Now we do low plus high divided by 2. Now low is our 0 and high is our 6. So 0 plus 6, 6. 6 divided by 2, 3. So first we divide the input from the third index. Now we again use divide strategy for each part. So 0 plus 3 is 3. 3 divided by 2 is 1. Now we divide from here. For our simplicity we give here numbering. This is 1, this is 2. Again now we divide right part. So 4 plus 6, 10. 10 divided by 2 is 5. So this is also 2. We divide each column one by one. So now we divide for third time. 0 plus 1 is 1. 1 divided by 2 is 0. So this is now we divided third time. Now 2 plus 3, 5. 5 divided by 2 is 2. So this is third time we divide. Now this is 9 divided by 2 is 4, and here no element is remaining to divide. So third. So how we divide? At that direction we merge, means now we merge third divide first, then we merge second division, then 1. So first we merge all the 3. We see one more example of the merge sort, how to divide the given input. So as I say, we do low plus high divided by 2. So 0 plus 9 is 9. 9 divided by 2 is 4. So we divide from the 4. For our simplicity, I mention here 1 because first time I divide only 2 parts. Then again we divide for the left side and the right side. So 0 plus 4 is 4 divided by 2 is 2. So now we divide here. So this divide by second time. Now again 5 plus 9 is 14. 14 divided by 2 is 7. So these 5 elements are each side, but when we divide again, then 3 2. In this way we divide these 5 elements. So for that I give the index for each element of the input for my simplicity. Now we divide for the third time. So what we do, again low plus high. 0 plus 2 2. 2 divided by 1 is 1. 2 divided by 2 is 1. So we divide from the 2. This is the third time we divide. Now 3 plus 4 7. 7 divided by 2 is 3. Now 5 plus 7 it's 12. 12 divided by 2 is 6. This is also third time we divide. Now 8 plus 9 17. 17 divided by 2 is 8. So this is the third time we divide. Now again here also 2 elements are the remaining to divide, and right side also. So again we divide here. 0 plus 1. 1 divided by 2 is 0. Now this is the fourth time we divide. Now how we merge, how we divide, at the opposite side we merge them, means now we merge from the fourth division, then third division, add in this way. So let's see how we merge them. Now we compare those two elements of the fourth division, 13 and 20. So these are the, no need to swap them because 13 is the smallest from the 20. So this 30 20 stay as it is. Now this third division is as it is, right? All the remaining divisions don't be change them because first only we merge fourth division, not third or second one. This one. Now we want to merge fourth division. So 1 3. Again we not change because 1 is the smallest to third. 3. Now remaining all are the right as it is. 2 15 12. Now we merge third division. Here is 9. Now 13 20 17 we sort. Now 13 17 20 we merge all the element by increment order. Now this is the second division. We want only merge third division. So now this is the third division. So 9 10 we change the position of 9 and 10 because 9 is the smaller than 10. Now this first one is as it is. Now third division. Here 1 3 18. Now third division, so 12 is the smaller than 15. Now we merge second division. Now we merge these two parts in the increment order. So now this is our last answer of the sorted array. I hope you get the idea how to sort the merge sort. So quick sort is also used, the divide and the conquer strategy. Here a division on the basis of the pivotal element. The first element of the pivot element of the input. The pivot element placed in such a way that all number less than pivot is left hand side and all number greater than pivot is right hand side of the pivot element. Again quick sort continue on two parts of the pivot. Here the smallest problem comprises of 0 or 1 element. So how we solve, let's we see. So this first element is our pivot element. So this 32 is our now pivot element. Now we mention the second one is the I. Second element we give I is the naming, and the last term which is the high we give j. Now we check, we want I always smaller than the pivot and j is always greater than the pivot. So 37 is the smaller than 32? No. And j is the greater than 32? No. Greater than 32? No. And j is the greater than 32? No. Then we swap them. And I plus plus j minus minus. So this 32. Now we swap I and j. So here now 22. This 33, 11, 38, 41. And now here is the 37. So this is our pivot element. Now I is here and j is here. Now again we check. I is the smaller than pivot element? Yes. So I plus plus. Now again I is the smaller than pivot element? Yes. Now again I plus plus. If I is the smaller than pivot element, then we perform I plus plus operation. So now we check. I is the smaller than pivot element? No. So now we check for the j. J is the greater than pivot element? Yes. J minus minus. Now j minus minus. Now j is the greater than pivot element? Yes. Now again j minus minus. If we cross I with j, means when I is greater than j, then that time we swap pivot element with j element. This j element we swap with pivot element. So now 11 is here. This is 22, 23, and the jth element is 32. This is our pivot element, and remaining all are the same: 38, 41, 37. Now the pivot element is 11. Now all the procedure as the same. Now our I is here and j is here. Now again we check. I is smaller than pivot element? No. J is greater than pivot element? Yes. J minus minus. J is greater than pivot element? Yes. J minus minus. Now j is greater than pivot element? Yes. Now again j minus minus. Now we cross to the I. So in this way we perform all the operations. Now our j is here and this is our pivot element. Now again our I is here and j is also here. So now 23 is our pivot element. Now we check for the left hand side. So first element is our 38. From the right hand side part. So this is our pivotal element. So I is here, j is here. So same procedure we follow. We want I is the smaller than pivotal element and j is the greater than pivotal element, and if not, then swap them. So here we swap. I is smaller than pivotal element, yes, so I plus plus, and j is greater than pivotal element, yes, j minus minus, j cross to the I, then j's element swap with pivot, and now here 37 is the pivot. So in this way we perform the quick sort, and at the end we get the sorted array. Now the radix sort or the bucket sort. So in this sort we go from unit place, then the 10 place and the 100 place. In this way we do operation on the integers. So here the first unit place is 8, 3, 2, 2. We draw here buckets for each elements. We mention index 0, 1, 2, 3, 4, 5, 7, and then we put each element in this bucket. So if the index unit place is 8, then we put this value in the 8 bucket, 8 number bucket. If the unit place is 3, then this value we put in 3rd bucket. So in this way we put all these values in the bucket. So 8 is go in the 8 number bucket, 3 is go in 3rd number bucket. This is like queue. Once we complete the unit place, then we move for the tens place. For that, how we put the values in the same way we take out from the bucket. So first we put 0, 4, 2 in the 2nd number bucket. So we take out first 0, 4, 2 and then 3, 4, 2. In this way we take out all the numbers from the bucket. Now we compare 10 place, and again we put those value in the correct bucket number. So first middle term 10 place is 4, so this place in the 4th number bucket. Again 10 place is 4, so we put in the 4th number bucket. So third one is the 9, so we put this value in the 9th number bucket. So in this way we cover all the values. Now we move for the 10 place, 100 place, and in the same way we all the procedure perform same, and at the end we get the sorted array. Now the last sort is the heap sort. So first we form the heap and then we sort them. So how to build heap we see. First we take 32. So this is the 32. We know the condition of the heap sort. Every time the parent is greater than child. So first element has no any condition. This is the 32. Then we take 37. First we draw for the left child, then we draw right child. So this is the 37. Now 37 is the greater than 32. We want always parent node is greater than the child node. So now in second step we swap them. So now 37 is swapped with 32. So now the third element is 23. So this is on right side 23. So the condition is same, parent is greater than child. So no any issue here. Now the next element is 11. So again we first draw for the left side and left child. So here is the 11. Now the second one is 38. So 38 we draw here, but 38 is the greater than all the remaining nodes. So we want 38 at the root node. So first we swap 38 with 32, then now 38 is here and 32 is here. Now we swap this 38 to 37. So at the end we get 38. Here is 37 because we swap here. Now this 23 as it is. Here is 11 and here is the 32. So now the next element is 41. So this go for the right child. Here is the 41, but the condition of the heap is false here. So again we swap 41 with 23. Now here is 41, here is the 23. Now again 41 with 38. So here 41 and here is 38. Now our heap is like here is the 37, 11, 32 and here is 38 and 23. Now the next element is the 22. So this is again go here for the right child. So all the condition means all the parent nodes are the greater than child node. So now here our heap is created. Now we see how to sort the heap sort. I hope you get idea about the how to build the heap. We see one more example to how to build the heap. So first we take first element. Now we take second element. First we connect at the left child. Now we take third element. This connect for the right child. 5, 3. The condition we want every time the parent node is greater than the child node. Now the fourth element is 1. So we cover all left child. Now this fourth element go here of the left child. So here is 1. Now next element is 8. This is go here right child. First we go for left child, then we go for right child. But now here this is not a heap because the child node value is greater than the parent node. So we swap them. So here we swap 8 with 5. So now here is 5, here is 8. Again we swap this 8 with 6. So now 8 is here and 6 is here. So now our new graph is 8. Here is the 6, this 3, this is the 1 and here is the 5. Now the second element is 8. 8 is completed. Now the 7. So first we take root node, then we complete left child, then right child. Again we move for left child and right child. Now here for the right child of the root node we draw first left child. So 7 is go here, but this is not a heap. Again we swap 7 with 3. So 3 is here, 7 is here. Now this is enough for the swapping. So now the next step is like 6, 7. This left child, right child, and here is the 3. Now the next node is 2. So this 2 is go here for the right child. Now the next node is 4. So again we first completed left child all, then right child. So 4 is go here, but this is not a heap. So we swap 1 with 4. So now 1 is here, 4 is here. Again there is no any swapping is required. So now last heap is like 8, 6, 7, 3, 2, and sorry, here is a 4 and here is 1. So this is our heap. Now how we sort, let's we see. So how the sort heap, we see the previous example. So write all the element sequence wise in a queue. So for first write root node, then left child, then right child, again see here, this is the root node, this is the left child, this is right child, again 11 is the left child of the 37. Don't write right and left, always write first left child, then right child. So 11, then 32, then 23, 22, then swap 41 with 22. When we swap 41 with 22, then our tree is now like this, 22 and 41 is here. So now 41 go in appropriate position. Now again build a correct heap, but now don't mention 41 because we put 41 in their appropriate position. So now our tree is like this. Now again create a heap, so swap them. So we swap 22 with 38, then 38 with 23. So 22 go at the last of the node and the heap is now created. We not put 22 here because our condition, we know parent node is always greater. So if we swap 22 with 37, then 37 is here and 37 is now parent and the child node is 38 is present. So this is not create a heap. So only one swap is required with 38 and 22. So this is our now next heap. All these tree write in a queue for each step. Now we swap 38 with 22. We sorted our tree from the right side. So always first create a heap, then sorted left element with the right element with the left element. Now we swap 38 with 22. Now again our tree is changed. Now 22 go at the root node. So in this way all the steps are the cover here. These are all the same procedure we follow. First we create a tree. First we create a heap, then we swap from the right side of the elements, and all the procedure we repeat again and again. So at the end only 3 elements are the remaining here. When we swap those elements, then at the end we get only 2 elements, and which is already sorted. So in this way we sort the given input. I hope you get the idea about this.